Hello and welcome to the Road and Sports webinar for playout. I'm Dan Roth, Product Manager for playout, and I'm here today to talk to you about some of the solutions that Gallium and StreamMaster can provide to our customers with the problems that they are faced with today. Firstly, Road and Sports do playout. Yes, R&S, well known for their precision test equipment, acquired Pixel Power in 2018. Pixel Power, we have a great heritage with broadcast graphics equipment. In 2012, Pixel Power started to develop an automation workflow solution, which grew from the already established graphics workflow product, Pixel Promo. Then, taking the experience of Brandmaster and over 30 years of graphic engine development, created the video processing technology, StreamMaster. Now supported by Road and Sports for nearly 5 years, we've been able to develop and integrate with the wider media portfolio. And you can see here we've been able to provide a complete end-to-end solution. That was a brief introduction to our past and present, and now I'd like to take a short amount of time to remind ourselves where automated playout started and how and why we got to where we are today. As I'm sure many of you are aware, there have been some large leaps in technology recently, allowing for some significant changes in how a playout solution is considered and built. Some 20 or more so years ago, the playout solution was an automation system driving a single playlist and instructing individual devices to compile the schedule's intent. Often taking up racks of space in a central apparatus room, equipped with all the required infrastructure and delivery and distribution for the media. This was followed by more sophisticated automation systems that would allow for more than just one playlist to be controlled, but still the individual devices under its control. However, these devices became more powerful and efficient in space. Fast forward to 10 years or so, and the channel in a box was launched into the market. This was a single apparatus, usually 2 or 3 large, designed to replace a full rack space of equipment from video servers to data inserters. The solution for playout is still present today and still widely developed to produce much of the playout services, adapting most recently with the introduction of baseband IPIO, opening the door to acquire some of IT policies and some of the best practices in a bigger market. The separation or next step for many of these products is the ability to integrate into many of the new emerging environments. Creating a software-defined application allows customers to deploy the product onto off-the-shelf servers, or COTS, which is an important entry point to the less traditional environments like the CAR we mentioned before. Although this does not exclude it from these environments either. Both Gallium and StreamMaster are software defined. The image here shows StreamMaster's software defined architecture can be broken down, somewhat like the hardware devices taking up racks of space in the past. However, as this is software only, it allows for just the components needed to provide the solution. Again, as this is software, we have a far easier path to add other components when required. Other benefits are the development path. It means we do not have to refactor as a monolithic piece of software when there are new requirements. So for example, support for new higher quality, low latency stream codecs and compression standards that are becoming more favoured can be added to just the program stream encoder, this one in the 4th column, to create new outputs. Or the media stream decoder in the 2nd output for inputs. The point here is that the changes do not have to affect fundamental relationships with the rest of the components, or can be omitted if not required at all for individual solutions. For example, a VOD workflow here. It makes sense for additional playout to help drive the demand for the VOD asset. Playout holds the schedule for the intended output and therefore holds the information for where something is expected to be and by when. This could be as simple as a file delivery to a playout engine, or in the case of the 2 live programs seen here in the live linear channels, may also be required to become an asset to be uploaded to the network's on-demand platform. Let's take a look at what's needed to happen to the asset that is required for the VOD delivery. Firstly, the live show needs to become a file. Therefore, an ingest request is required. It is likely that it would need to be a clean feed and not branded output that would go out live to the linear outputs. Maybe there's a need to create highlight segments, bite-sized clips of the live programs. Maybe these clips need bookends for graphics. Maybe they need to be applied with subtitles, extra languages. The list goes on. Most importantly for live, it is unpredictable. It is quite normal for them not to know when breaks occur or how long the duration of the live event will be, which will require manual intervention. This is traditionally done in the traditional playout environment. In today's world, instant access to the newly created assets is expected. With these demands and drive for efficiency, this became the base principles behind the flexibility of the Gallium and StreamMaster technologies. As mentioned, both Gallium and StreamMaster are software defined. We promote them both as technologies, from which we can create products that provide solutions for these issues. In the live to VOD example, the products Gallium Playout and Factory are able to achieve the business logic around the rules that can be applied to the playlist to instruct StreamMaster deliver and render to produce the content that is required in the right locations. As software-defined solutions, the architecture can be deployed into the appropriate environments for efficiency and distribution and accessibility to the resources required. So let's take a look at this. In the VOD example, the scenarios described in the earlier slides are one of many solutions that can be achieved with Gallium orchestrating the predetermined workflows and instructions that StreamMaster need to produce the desired output. Ingesting and using unique secondary-based rules, we can rebrand content with the graphics workflows to manipulate existing templates from a particular channel and other unique secondary events required for the VOD asset as a render request to StreamMaster, which will produce the composed file in a predefined format. This can also apply to existing file-based material which is required on the VOD platform, driven by the same workflow. If the asset requires further mastering and enhancement, obviously the asset can be delivered to something like Roden Swartz Clipster, the gold standard mastering application for further treatment before it makes its way to the VOD platform. This is just one example, but as Playout has a logical link to asset management, delivery and distribution, this Venn diagram illustrates how many of the jobs can be driven by Playout and how many others and more will potentially be required in the future, all with their own workflows. Therefore, having a single technology stack providing solutions for these jobs makes sense. And it's how Gallium and StreamMaster works today, and along with the rest of the RNS media portfolio will be developed moving forward. Of course, what we know as traditional linear playout is still very important. Live programming is becoming an ever-growing requirement. A reliable, adjustable playlist with the ability to handle contingency scenarios that often come up with live programming is essential, and something Gallium and StreamMaster solutions offer. But what about being able to preview an entire junction within the UI? Here I'm selecting concurrent events into the playlist using Gallium UI PPMC. The highlighted group of ordered scheduled events can be previewed to see how their transitions might look. However, this is not just the primary events, but it also includes secondary graphics. And not just pre-rendered graphics, but dynamic ones also, showing you exactly what is coming up in the data sources that it is using. This is just one example of Gallium and StreamMaster working together. The demonstration there was StreamMaster rendering out to a player in the UI. But this was the same StreamMaster software that runs on the high-end COTS hardware to create your broadcast level outputs, providing further confidence in how the schedule intent will look. The same operation being carried out in individual assets inside the UI, or if desired, a dedicated StreamMaster for baseband I/O using the same UI. This is dependent on the quality control checks you are wishing to carry out. With supporting hardware, StreamMaster can be used to output many different formats, from SDI to 2110 to compressed IP. In addition, it is designed to allow a choice of points in the pipeline you want to take outputs from, allowing things like clean feed outputs or partially clean, maybe just the station logo, depending on your requirements. The Gallium UI itself offers a number of different configurable choices to the user. For example, you can aggregate a number of channels just to filter for specific criteria to create a monitoring by exception panel. We also have different master control options for bus switching and audio manipulation. Finally, the UI itself is tailorable. So you don't like the way things look or the way that I've shown things today, these can be moved around and saved as different layouts. Although I've not been able to explain or show every possible workflow today, I hope it has been worthwhile introduction into what is possible when using Gallium and StreamMaster solutions. I'd like to thank you for today for your time and look forward to the QA that's coming up in a moment.